All right, so internet decided to cut out on that last one. All right, so we were just at the point where y equals 3x squared, where we solved for that. We could have come over here and solved x equals 2y and plugged in as well. The only difference is we have to raise that to a power when we plug into that x over in the first equation. So by using y equals 3x squared, we get x minus 2 times 3x squared. So x minus 6x squared equals 0. You could factor out an x, so x equals 0, or 1 minus 6x equals 0, which means 1 equals 6x, which means x equals 1 over 6. So in this case, we're going to have 2 points that we're going to have to plug in here, y equals 3x squared, to get our y values for. So we plug in 0, we get y equals 0. So we get the point 0, 0. You plug in 1 6, so 3 times 1 6 squared gives us 3 over 36, which will reduce to 1 over 12. So we have two critical points, 0 0 and 1 6 comma 1 12 are our two critical points here. So going back to our partial derivatives that we see at the top of the page, we need to find d for both of our critical points. So for 0 0, for fxx, we get negative 6 times 0. For fyy, we get negative 2. So then fxy at 0 0 gives us 1. So we're going to get 0 minus 1, which is negative 1. It's a negative value. It's less than 0. It's a saddle point. So it is neither a relative max nor a relative min. For 1 6, negative 6 times 1 6 is going to give us negative 1. And then we are going to get, so negative 1 times negative 2 minus 1 gives us 2 minus 1, which is 1. It's positive. fxx is going to be negative. So by our next slide here, since d is less than 0, it's neither a maximum nor a minimum point at 0 0, but a saddle point. So d is greater than 0 for the point 1 6 comma 1 12. fxx is less than 0, so it has a relative maximum. So then we take this point of 1 6 comma 1 12, we plug into the original. So we get 1 over 72 minus 1 over 216 minus 1 over 144. When we simplify, we get a relative maximum value of 1 over 432. So a firm produces two kinds of golf balls, one that sells for $3 and one priced at $2. The total revenue in thousands of dollars from the sale of X thousand balls at $3 each and Y thousand at $2 each is given by R of XY equals 3X plus 2Y. The company determines that the total cost in thousands of dollars of producing X thousand of the $3 ball and Y thousand the $2 ball is given by the following function. C of xy equals 2x squared minus 2xy plus y squared minus 9x plus 6y plus 7. So we're going to use the same exact principles. It says how many balls of each type must be produced and sold in order to maximize profit. So the total profit function P of xy is given by R of xy minus C of xy. So 3x plus 2y minus the entire quantity of 2x squared minus 2xy plus y squared minus 9x plus 6y plus 7. P of xy is equal to negative 2x squared plus 2xy minus y squared plus 12x minus 4y minus 7. So that's going to be the function that we're going to use starting on the next slide. So our profit here, so P sub x is minus 4x plus 2y plus 12. Pxx is -4. Pxy is 2. For Py, we get 2x minus 2y minus 4. Pyy, we get -2. So we got to solve the system of equations. -4x plus 2y plus 12 equals 0, and 2x minus 2y minus 4 equals 0. So in this case, we're actually going to have to solve this system of equations unless you wanted to do a little bit ugly of a substitution in this case. So if we add the two equations together from the previous slide, so if we just add these, we get -2x plus 8 equals 0, which is what we're looking at here. So -2x equals -8, so x equals 4. So once we know our x equals 4, we could plug into either one of those two equations, a px or py, to find y. So 2x minus 2y minus 4 equals 0. So 2 times 4 is 8, minus 2y minus 4 equals 0 gives us the +4. So then -2y equals -4, so y equals 2. So in this case, we're looking at the point 4, 2 is the only critical point we have. So we can find our d function, pxx at 4, 2 is -4, pyy is -2, pxy is 2. So we're going to get, so this line right here gives us 8 minus 4, which is 4, so d is greater than 0. Since d is greater than 0 and pxx is less than 0, it follows that p has a relative maximum at 4, 2. So in order to maximize profit, the company must produce and sell 4,000 of the $3 golf ball and 2,000 of the $2 golf ball. The maximum profit will be, when we plug in the 0.42, it gives us 13, or if we think about it in terms of the problem, it's $13,000 is what we end up making. Be sure to keep in mind that even though we're using X and Y, that we have to remember that X was the $3 golf ball and Y was the $2 golf ball. So we always got to keep it together on what we're actually finding here and everything.